Thanks, Mike. And wow, lights are bright. Thanks, Mike. And I also have to give credit for Mike. The PhotoNICs part of this is actually Mike's invention. I stole it from him. Anyway, what I'm going to talk about today is something of a gateway from the NIC, the network interface card, which is something of a gateway between the traditional network that, the Ethernet network, to this new network that we're calling sometimes the back-end network, or the compute-oriented network. So I'll talk a little bit about the NIC, first of all. I'll talk about something called OCP 3.0. I'll talk about if the NIC is an appropriate home for silicon photonics or not, and my changing views on that. And then I'll talk about linear pluggable optics and whether it is at home in the NIC. And just as a preview, I think it can find a nice home there. And then finally, I'll finish it off by talking about the NIC of tomorrow. Okay, and speaking of NIC, which I think is like slang for steal, I wish I was able to steal one of Nathan's slides from earlier this morning, because he had a much better slide here, of the OIF taxonomy that relates how the different pieces of the compute network fit together to the front-end networks, as I guess, at least in his diagram, they called it. The NIC is what lies in between those networks. On one side, it has this networking Ethernet, at least the NICs of today, have this networking Ethernet interface, and their side it typically has a PCIe interface. These NICs come from the NICs that used to be in PCs, and some of them even look like the ones that used to fit in those desktop PCs. And while I'll be talking about the NIC, most of the remaining talks in this session will talk about the optical interconnects in this, what is increasingly called the back-end network. I also want to mention that this is a very schematic diagram, a network interface card. Actually, you can put compute elements inside of it. You can put memory elements inside of it as part of this whole idea of, any element can be anywhere, which is, the point of disaggregation. At my company, Dell Technologies, when someone says OCP, and they say it all the time, they mean nothing about this place we are, or this conference, or this group, or this organization. They're talking about a type of a NIC. There's the OCP 3.0 specification, which was defined by our Open Compute project, and actually has been almost a game changer in the industry, in that we now have this standard, NIC form factor. So it's, and if you go in the trade show floor, it's all over the place. There are the OCP 3.0 NICs. And as a, I have to give a shout out to some colleagues of mine from both Dell Technologies, Broadcom, and Meta. We have another paper and another session on NICs at 800G and future generations of PCIe. So the NIC is something that is definitely evolving, and the OCP NIC is evolving with it. So today's NIC, what I mean by today is maybe yesterday or maybe 3 months ago. It's something that connects servers to a top-of-rack switch, and these are the typical ways that NICs are deployed in a data center. It uses a lot of passive copper, and the amount of passive copper, or the distance you can go through in the passive copper, decreases as you get to higher speeds. At 100G per lane, you can get, well, according to Ram Valaga, you can get 4 meters. If you read his blog, if you use Broadcom SerDes on both ends. But the length of this copper also depends on thickness, on the gauge thickness of that copper cable. And in general, 3 meters will get you 1 rack of servers. And in the general data center world, that kind of worked out nicely, because you had 1 rack of servers, you had one rack and top of rack switch, and it all worked out nicely. Things seem to be getting a little bit bigger in the newer world that we're in. But the copper is very important because it's the lowest cost solution. Also, more interesting, more recently on the market is active electrical cables. You can actually probably at 100 G per lane get up to maybe 7 meters. In fact, I saw a device on the floor yesterday, but it's 26 gauge, so it's not very flexible at all. And then optics is needed for anything longer. So in some sense, the market for optics for building at least in kind of Ethernet-based AI fabric really starts at like 7 meters and maybe even below that. So if I tell our vendors a lot of times, if we can just get to 30 meters, we think we've got most of the market wrapped up. So I mean that's just the kind of reality, from 7 to 30 or 40 meters, with most demand at the low end. Okay, so is NIC a home for CPO? These are possible homes for CPO. This is from a Microsoft slide. Looks very similar to the earlier Microsoft slide from this morning. But most of the work with CPO, co-packaged optics, was focused on the switch, which is in the lower left-hand corner there. And the NIC is just above it, the compute endpoint. That seems to have changed. I think the consensus, or a near consensus, is that the Ethernet switch is going to be using pluggable optics for at least 1 or 2 more generations. But the focus of, and perhaps why so many people are here at this conference, is the focus of, the CPO world is now on the GPU interconnect, or clusters of GPUs. And I want to just recall, why are we going to CPO? Well, it's to save power because you don't have that long trace, electrical trace on the board that requires power to get the increasingly high-speed signals over. So a few years ago, I used to think, well, this seems to be a disconnect because people want to put CPO on switches, but what about servers? Servers typically only need 1 or 2 lanes. And does silicon photonics make sense at that kind of scale? I mean, silicon photonics makes a lot of sense if you have 512 connections that you need to make and you want to put it all in one place. But if you just have 1 or 2, so I thought there was a disconnect. But within the last year, the NIC bandwidth expansion has been surging due to AI, and NICs, there are NICs out there that are 800G NICs that use 800G lanes. So maybe CPO does have a place in NICs. But there's another surprising competitor in the NIC world, which is linear pluggable optics, which is introduced at OFC this year and seems to be a pretty big part of this discussion at this show. So just to show what linear pluggable optics looks like, in the old-fashioned high-speed link for PAM4 or the high-speed world was had DSP SerDes in the both on the terminal ends as well as in the transceivers, and there was a lot of work being done in the CPO world where people were saying, hey, I don't think we need to have a SerDes in our optical chip or chiplet. Let's just kind of do a linear drive. And to the surprise of everyone, including me, it turned out that the SerDes that have come out recently, like the Tomahawk 5 or the NVIDIA Spectrum 4, have been so powerful that you could put maybe up to 15 or 18 dB of electrical loss between that SerDes and the transceiver. And it works, or you can make it work, or you can adjust it to work. And it even works with a wide variety of optical transceiver devices, like all the way from VCSELs to EMLs, to silicon photonics. So what this buys you is kind of a lot. You get rid of the SerDes, that's cost. The SerDes is one of the highest cost components in an optical transceiver. You get rid of the power of the SerDes. And finally, there's even a bonus, you get rid of the latency that the DSP causes. And what you get is you get a CPO like power reduction without the baggage. This is a slide I stole from Andy's talk, or this is a table I stole from Andy's talk at OFC. But what you can see, it's a comparison between LPO and CPO. And you know, in the end, they come out pretty similar. And the reason is they both use linear drive, but CPO kind of suffers from having to have that external laser and all the optical losses to get that light into your transceiver. And linear pluggable optics suffer because they have that long trace. I know there was an argument in one of the last sessions about, really, are they the same? For the purposes of this talk, I'm going to say that they're the same. But the point is that if the reason for moving to co-packaged optics was for power, you're getting most of the way there using LPO. So critical issues, there's an increasing amount of data, but it is still very anecdotal. And people have, I've heard a lot of folklore about it. People will show me data, they don't let me copy it. So anyway, it only works with the most advanced SerDes out there. And in fact, the reason it works is really only known by the companies that make those SerDes. So all these standards are being built around this black box that nobody really knows how it works. And I think it's a little squishy. I think the standards, I don't know how all that's going to work out. It's in a new world, let's put it that way. And I think interoperability between any 100G port on any 100G switch and another switch, I don't think that's happening very soon because there are already 100G SerDes that we know do not work, but yet are fully IEEE 802.3CK compliant. So the first movers in the linear pluggable optic area will solve not this, I want to work with everything anytime, but more well-bounded, well-defined problems. So interestingly, one of the big problems that you have with using LPO and switches is the trace length between all the different ports, maybe 32 or 64 different ports, is going to vary by quite a bit. However, in a NIC, the NIC card is small. It's small. It's smaller than my hand. It's only about 2.5 to 5 centimeters. So it's a very short length. And there's really only one or two of these, so there's not that much variation. So with LPO, a pluggable optics now becomes NPO, near package optics. And at that point, you really have to ask yourself, would I ever go to CPO just for that extra inch of, or 3 centimeters of electrical link loss saving? I don't know. I don't see it happening. So whereas I could have been convinced that CPO might happen in servers 6 months ago, I'm not convinced it will happen, at least not on the networking side. So here's just an example of the kind of power savings that you might see. A typical NIC, a 400 gigabit NIC, a NIC with a bandwidth of 400 gigabits and a 4x100G port, the NIC alone, forget about the optics, will consume about 16 watts. If I fully loaded that with 400G of optics, that would probably be around a 7-watt optic, and I'm actually being a little bit generous today. However, if I used let's say, call it a VCSEL-based LPO, I would consume 2 watts. So you can see that I go from a situation where I have almost half the power, close to half the power being consumed by my optics to something where I have more like an eighth. And I want to emphasize, the NIC is in a much more thermally constrained, power constrained environment than a top of rack switch. We're already seeing servers and so forth that are liquid cooled. There's a lot more, there's a big bang for the buck at the NIC compared to the switch for using LPO. So I just want to finish this off. Remember, the NIC is kind of the gateway to the back-end network, and by talking about the NIC of tomorrow. First question is there a NIC of tomorrow? I mean, the NIC is kind of an artifact, right? Because you can really move everything around, and embed NICs and things and so forth. But I do believe it will exist. Artifacts have ecosystems, and ecosystems have a lot of economic value. And the first thing I can tell you is that the NIC of tomorrow is being specified today by OCP. It's not necessarily the optical NIC of tomorrow, but eventually it will all be optics. On the network side, it's going to have something like Ethernet, which might be Ultra Ethernet, via linear pluggable optics. And then on the host side, I don't want to I don't want to bias the jury. We have a number of talks that follow mine about various different approaches to the optical interconnects on the back-end network. And maybe after seeing all those, I'll make a decision on what I think the ultimate back-end side optical interconnect is. But it definitely will be optical. So that, I think, is the end of my talk.
Time for questions, if people have any. Why don't you go to the microphone?
Ollie, it's surprising to see you.
Oh, yes. Hi again. So in case of CPO, have you also considered the fiber pigtail? Because that can be very costly, for especially for few lanes.
Yes. Yes. The fiber pigtail is kind of embedded in the cost of CPO, and especially for a few lanes, it seems to be
overriding the
right.
cost.
So my point was that I was thinking that with the AI bandwidth explosion, we might have more lanes on NICs, which we're getting, and it might start to make more sense.
Okay.
But with LPO, which is effectively NPO for a NIC, I don't think we're going to see, at least on the network side, co-packaged optics on a NIC.
What about putting the optics directly on the board? Just get rid of all the package. What's wrong with that? Or even build a socket.
So that's very old school. That's the way everything used to be done.
Yeah.
People like the pluggable model. Going away from the pluggable model does not make people that happy. Then you'd have to have a different kind of NICs and increase your number of SKUs. Okay.
Any other questions? Okay, let's thank David.